Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams B, FM, IFM, and LTAM that I teach. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax deductible, to the extent allowed by law, donation to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem for today, for exam P on probability. Let x and y be continuous random variables with joint density function f sub xy of xy equal to 8xy for x greater than or equal to 0, less than or equal to y, less than or equal to 1, and 0 otherwise. And let w equal to xy. What is the density function of w where non-zero? So let us work on the solution of this problem. We have a figure here in which two-dimensional figure showing x and y axis, and in there we have this triangle indicated, and that's a triangle where the conditions given in the problem are met for the density to be positive and given by the formula that is given in the problem. So let's look back at that formula again. So here it is. This is the formula, and the condition for the density to be positive, to be 8xy, was that x was greater than or equal to 0, less than or equal to y. So x has to lie below y. Y has to be given greater than x, and the line where y equals x is the line with slope 1 going through the origin, and y is bigger than x above that line, and then we have both x and y between 0 and 1. That's precisely the triangle that you see here. The conditions are met, and the density is positive only in that triangle. So in the figure below, note that the region where the density is positive, the triangle bordered by lines x equals 0, that's the line here where x equals 0, y equals 1, that's the line here, and y equals x. And the shaded region below the curve where xy is equal to w, or equivalently y is equal to w over x. This is a hyperbola, and then we want to be below that hyperbola. And this shaded region describes the event that y is less than or equal to w over x for a specific value of w, and probability of which we will be calculating. And the reason why we're calculating it because probability that w is less than or equal to w is the cumulative distribution function of a random variable w, which is the same as xy. So note that the line y equals x and the hyperbola xy equals w intersect at the point xy such that x is equal to y, because y is on the line where y equals x, and that's equal to the square root of w, because if x is equal to y, then xy equals y is the same as x squared equals y, so that x is equal to square root of w, because we're only working with positive values of x and y between 0 and 1. And therefore, the f sub w of w is the probability that, which is the probability that w is less than or equal to w, is the probability that xy is less than or equal to w, which is the probability that y is less than or equal to w over x. And it's the integral of the density over that shaded region that I was trying to show you. And we can just take the integral of a density over that shaded region, but we have to split it into two integrals. One is the integral from 0 to the square root of w, where y runs from 0 to square root of w. that's the point in that hyperbola where the line intersects it. And then x runs from 0 to y. Well, x is less than or equal to y. That's the same equivalent statement. Of the density 8xy dx dy plus the integral from square root of w to 1 of the integral from 0 to w over y of 8xy dx dy. And now we just carefully calculate it. So the integral of 8xy with respect to x is 4x squared y, evaluated from 0 to 1. And then we take the integral from 0 to w of that result of that with respect to w, plus the integral from square root of w to 1 of, again, 4x squared y, evaluated from x equal to 0 to x equal to w over y. And then the last integral was with respect to y. So this becomes the integral from 0 to square root of w 4y cubed dy plus the integral from square root of w to 1 of 4yw over y dy. And that's y to the fourth, evaluated from y equals 0 to y equal to square root of w plus 4w squared natural logarithms of y. And natural logarithm of y is evaluated from y equal to square root of w to y equal to 1. And the first expression becomes w squared minus 0 plus 4w squared times ln of 1 minus ln of the square root of w. So this whole thing becomes w squared minus 4w squared times the natural logarithm of the square root of w. And the derivative of the cumulative distribution function is the density, and we're looking for the density. Well, what's the derivative of that? It's 2w minus 8w natural logarithm of the square root of w. So it's the derivative of 4w times the second expression. We're using the product rule, basically. Minus 4w squared. We leave it alone, and we take the derivative of the natural logarithm of the square root of w. So the derivative of natural logarithm is 1 over the whatever expression follows the natural logarithm. And then the derivative of square root of w is 1 over 2 square roots of w. And we evaluate all that. And take a look at the interesting thing that happens with the last expression. Square root of w times square root of w, well, that's w. And w squared divided by w is w. And 4 divided by 2 is 2. So this whole last expression is minus 2w. It cancels with the first one, and we end up with minus 8w ln of square root of w. Don't think that this is negative. The natural logarithm of a fraction is a negative number, so this ends up being positive, of course, which it should be because it's density. And that's answer A. Now we could also do this problem by using a bivariate transformation. So we let u equal to y and w equal to xy. We want the density of w, but if we're doing a bivariate transformation, we need two random variables. Then the inverse of that transformation is x equals w over u and y equals u, and the determinant of the matrix of the partial derivatives is the determinant of minus w over the matrix consisting of minus w over u squared, 1 over u, 1, 0, and that becomes minus 1 over u. And of course we're going to take the absolute value of that in the calculation. So note that the condition that 0 is less than or equal to x less than or equal to y less than or equal to 1 is equivalent to 0 less than or equal to w over u less than or equal to u less than or equal to 1, or equivalently 0 is less than or equal to w less than or equal to u squared less than or equal to 1. And then we conclude from the formula for the density, joint density, bivariate density of a transformed random variable, that f of sub uw of uw is f sub x y evaluated x and y that correspond to this pair uw times the absolute value of that determinant of the matrix that we just calculated above. So this becomes 8 times w over u times 1 over u, and therefore it's 8 on w over u for, as I said, 0 less than or equal to w less than or equal to u squared less than or equal to 1, and outside of that region the joint density is 0. Note that 0 less than or equal to w less than or equal to u squared less than or equal to 1 implies that square root of w is less than or equal to u, and that's less than or equal to 1. And this gives that f sub w of w is the integral over all possible values of u of that joint density, which is the integral from square root of w to 1 of 8w over u du. So 8w times the natural logarithm of u, evaluated from u equal to square root of w to u equal to 1, and that's a negative, minus 8w ln of the square root of w. It's not negative, as I mentioned before. And that's again answer A. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.